in thermodynamics, sometimes we have this question dealing with the heat of a reaction. And sometimes that word is used a little bit in a confusing way. If we look at the combustion of methane here, and I've made up the numbers, we can see that we have 1 mole of methane, our standard oxygen, carbon dioxide, and water gives us 500 kilojoules. But here, if I have ethane, it requires 2 moles of ethane to give us 500 kilojoules. There's some very standard stoichiometry in here that we should be able to say 1 of these goes to 500 and 2 ethanes goes to 500, so that we can convert energies and moles. But you have to be very careful with the wording here. When you have these delta H's with a balanced equation, you'll notice the units are just in kilojoules, but sometimes these are in kilojoules per reaction, or they'll say kilojoules per mole of reaction. And now the way that this is stated, that reaction means it just goes with all of these coefficients as stated. Okay. Sometimes it just says kilojoules. But when you're talking about the reaction, you're talking about all the coefficients giving you this total for the reaction. But notice how this changes. What if I wanted the enthalpy for this reaction in kilojoules per mole of methane, and this one in kilojoules per mole of ethane? Well, all of a sudden, I have to account for how many there actually are. This first one, there's only 1 methane, so it's still 500 kilojoules per mole of methane. But over here, I actually have 2 ethanes. So it's going to be 500 over 2. So it's going to be 250 kilojoules per mole of ethane. And it's very common, especially in a combustion reaction, to talk about the enthalpy per mole of your fuel, because the rest of these are just kind of part of the combustion reaction. This is really the important one we're focusing on, because that's the fuel that you're actually burning. So you have to be careful for questions. Are they asking about kilojoules per reaction, or the enthalpy of the full reaction? Do they use that word? Or are they talking about kilojoules per mole of your substance, your fuel? Because that's a different answer. This one would only be 250. So this enthalpy of the combustion per kilojoules per mole of your fuel is different. And likewise, that can go backwards. Another way, if you were given that the enthalpy is 250 kilojoules, and they tell you that that's per mole of C2H6, what's the enthalpy of the reaction? Well, then you'd actually have to consider the balanced equation, because this is labeled not for the full reaction, but just for one of your substances. So anytime you get an enthalpy of one of the substances by itself, unless there's a coefficient of 1 in the equation, you have to account for that coefficient in order to say, okay, let's actually balance this equation and get that the reaction is 500. So that phrase kilojoules by itself can go with a full balanced equation if it's for a reaction. It might say kilojoules per reaction or per mole of reaction, but it's different than per mole of a chemical. And you have to be careful for which one's being asked for.